All right, for our next topic today, we are going to react to. There's a scientist out there, Melvin Vopson, who claims that he now can prove that this universe that we exist in and all that we know and all the everything we observe and everything is a simulation. And he says this based on he's talking about the laws of physics and an analog to the second law of thermodynamics, which is that entropy will stay the same or increase. He calls it the second law of infodynamics, and that what he's observing and what he says he can prove is that in our, from an information standpoint, like the from a data standpoint, that entropy is not increasing, and then in fact it is lessening, and that's evidence of data compression. And which we observe, like internet streaming and stuff like that as a result of being able to stream video and stuff like that. The ability to compress data and so forth, data optimization, and it's quote unquote data optimization and compression. So it's how we send big files over the internet and then they show up big again on, or they're able to go big again once they get to the destination and so forth. And he's saying he has evidence of this in the universe. And so, which suggests that there's optimization that's going on. So Tunde, what was your reaction to this? Whether either the claim, which obviously he's not the first one to make, and dates, you can go to look at the Matrix or anything like that, or his supposed proof.
I was going to say that he's making me feel like the Matrix is real.
I think that's his point.
No, but well, that's going to be interesting because now not only do we have to figure out what happened before the Big Bang, we're going to have to figure out what's going on outside the simulation. Maybe they're the same, but no. On a serious note, it's interesting because a couple of things. One is I know we did a show. I mean, this is probably 2 years ago where we talked about how over human history, like over the last few thousand years, like whatever historian we were reading was saying that humans have always equated like how the body works and how certain things work based on whatever the going technology is at the time.
So I remember that. Yeah.
When it was like a couple thousand years ago where it was like aquifers and people starting to have the technology to move water around for certain uses, they would think that the body flowed like a river. Yeah. And that was all these analogies of canals and all this stuff within our bodies. And then it became more mechanical.
Industrial revolution, it became more mechanical. And then when you started having robot computers and stuff like that,
now it's computers. When he's talking about data and like you're saying about bandwidth, it's like, okay, could this just him imprinting on our most modern technologies today on what he thinks is running the universe? And then the second was just the idea of, the double split experiment for those in the audience that are nerdy enough to have watched these kind of YouTube videos. But the idea that at the quantum level, when observing particles, they can behave like waves, they can behave like specific dots, all that kind of stuff. So the idea is that by observing something, it actually changes its behavior. And so I think
which is a rule in quantum physics, by the way. If you observe something, you change it by observing it. Yeah.
So that's what I would love to ask this gentleman. Help us wrestle with that. The fact that you're making these observations, what you're observing now, can we even trust that it is what you believe it is? Because maybe by your observation, it actually changed its state. Yeah. So you can really get into some galaxy brain stuff, which I guess is the point here.
And to your first point, the context in which you're going to understand that is going to be limited by what our current level of understanding is. And that's the reason why people's analogies to how the brain or the body work always mirrored whatever the modern state of technology was, is because that's the only context that people had to explain it in. So it's not a coincidence that in the internet age, he's describing these things in the context of the way that the internet works. And so to me, and I mean, I think it's a complete fallacy. Now, whether or not we're in a simulation or not, I don't think is knowable from in the simulation. If this is a simulation, I don't think it's that we can ascertain that with any level of definitiveness from the inside. We'd have to be from the inside in order to observe it. There's certain like assumptions that he makes, though, to me that reveal the error. And that is I'll quote, we know the universe is expanding without the loss or gain of heat, which requires the total entropy of the universe to be constant. Well, see, the thing is, we don't know that the universe is expanding without, loss or gain of heat. Like, we think These are theories. We think that
Yeah.
the universe is expanding, and we've thought that for a few decades. But now there are people coming with information that suggests that that's not the case. And this is based on observation. And I say this, you'll hear me say this a lot when I'm talking about science. As the tools of observation improve, understanding more perspective can be gotten, and understanding can evolve. In the same way that when Galileo points, or Copernicus, but Galileo in particular points a telescope up and sees what's up there, our perspective of what's going on changes, because that is a better tool of observation. And so we're limited by our tools of observation. And all of this, like coming up with a kind of a unified theory of physics. Right now, we don't have one. We should be very clear about this. Physics as we know it in the regular world and physics as we understand on the quantum level don't match up. We cannot harmonize them yet. So someone like this, to me, is a leap or two past that. Like, let's work on harmonizing quantum physics with just normal physics before we start saying, okay, we figured out actually all of this other stuff. Because the quantum stuff, as you pointed out in your part, the quantum stuff doesn't even make sense to us yet. Like where you could be at two things, or something over here can affect something over there, and even though they're not touching or related or anything, and observing it, like I could go through a lot of these things.
Quantum entanglement. Yeah.
But observing something changes it, all that stuff. There's a lot of things with quantum that are completely foreign to us. And until we can harmonize that with, what we actually are observing in kind of the non-quantum area, we can't base further theories on a statement like we know the universe is expanding, because it's like, well, actually, what about all this dark matter and dark energy, which are called dark matter and dark energy because we just don't know what it is. That's not really dark. It's just, we're just calling it that until we figure out what it actually is.
Okay. I thought that you were going to say because the scientist is woke. That's why. Because they have to give it a chance on DEI. But, and that's why we're going to be told that we can't teach the quantum physics anymore in school.
But the dark energy and the dark matter is not even, well, it probably has something to do with the quantum stuff, but that's just normal astrophysics. Is like, oh yeah, there's all this gravity over here. We don't know what from, so we're going to call it dark matter. And then the dark energy, we think the universe is expanding. What's making it expand? I don't know. Dark energy. Okay, got it.
I think as like the James Webb telescope has shown that by increasing the ability to observe things in greater detail, let's put it that way, it's already started to upend some of the theories that we had, like the Hubble constant, which deals with this whole dark matter and the expanding, how the universe is expanding. So you're right. This going back to the whole simulation thing. You're right. It's like he's got a new theory based on other theories, but the theories that he has to base his new theory on are theories that aren't themselves yet proven. All of them, right?
And they're on shaky ground, right?
Yeah, that's what I mean. It's a real house of cards, which is interesting. So, this is why I don't think humans will ever solve it, because it's also, if you really get into the whole thing with multiverses and dimensions, if that stuff is all to be believed, the idea that we have evolved in a three-dimensional format. So if there are four or fifth dimensions, we just won't be able to comprehend them. It's interesting to think about. You literally can't comprehend something. Just like I can't really comprehend what it would be like to be alive in a two-dimensional simulation without, the third dimension there of kind of space and all that. So, this is all fun stuff.
Well, but from the comprehension standpoint, I would leave that open. Like it's not impossible because, for example, I think a good analogy here is radiation, and I mean just all types of electromagnetic, or the spectrum. So we look at visible light we can see, and up until 100 years ago, 200 years ago, that's all we knew that there was. We didn't know that there was other types of radiation going around. We didn't know about infrared. We didn't know about, all the other stuff, and so, ultraviolet, different things that we can't see. And so radio waves, again, we can't see them. We develop tools to be able to observe them first and then to use them. But that's the prerequisite, because that's again our powers of our powers being able to observe, being determinative of what we can understand. And so we may develop tools later on that allow us to observe, to go beyond our senses. Our eyes only allowed us to see certain things. We may develop tools to allow us, in the same way we did with radio waves and all that, to see and manipulate other stuff. But until that happens, he's not saying I can measure more stuff now, or like I've developed a new tool. He's just saying, hey, based on what we know so far, here's what I think. So from that standpoint, I think it's limited. I commend him for the attempt, but again, like I think he's building it, as I think you put it well. He's building it on a house of cards that we're going to have to look at and say, okay, well, but a lot of this other stuff, it might go by the wayside by what James Webb tells us in 2 months anyway. So, tread carefully, sir, until we can figure out a better way to measure.
Let's just hope when he finds out the books aren't banned. So,
well, he might be put on house arrest. Like if we end up with, like if we're in a religion governed society, because that's what happened to Galileo, but nonetheless. So, but we appreciate everybody for joining us on this part. We'll have one more part for today's show. And so please join us for that as well.